A critical mistake when feature scaling in machine learning is fitting the scalar on test data. So what does fitting the scalar actually mean? Well, fitting a scalar means calculating statistics, like say mean, standard deviation, minimum, maximum, from the data that the scalar will use to transform features. And this might be better explained with an example. So check out this Python code right here. What we do is we have our data, which is an array of, we could say this column here are ages, and this column here are salaries. What we do is we use a standard scalar from the scikit-learn Python library, and then we use this scalar, we fit the data onto it, which means it learns the mean and standard deviation from the data. Then we print out this mean, and we print out the standard deviation. So this is the mean for each of these columns, and the standard deviation for each of these columns. But the critical mistake that we're making here is we're fitting all of the data. Instead, what we want to do is split the data into training and test data. So the correct approach is first, we split the data into test and training data. Then we fit the scalar only on the training data. And then we transform both the training and test data using the scalar fitted on the training data. So let's see that in action right here. So we have our dummy data, age and salary again, and then we have our dependent variable. What we do here is we split the data. So we have our training for X, test for X, Y training, and Y test. We create a test size, which is 33% or a third of the data. So a third of this here. We create our standard scalar. We fit and transform on the training data, and we don't fit on the test data. All we do is transform the test data with the scalar that's been fit on the training data. And then we can print out the scaled training data and the scaled test data separately. And so this ensures that your model evaluation is fair and realistic. But so you might be asking, why do we only fit on the training data? And that's because the training data simulates what your model knows when learning. The test data simulates new or unseen data to evaluate your model's performance. So if you fit the scalar on test data, you're letting your model learn information from the future, or the test set, which is causing data leakage. And this artificially inflates your model's performance and gives a false sense of accuracy. I want to thank you for liking and subscribing. Check out my software and courses in the description. Take it easy.